All right. So I'm James Feist. I am the original implementer and maintainer currently for Entity Manager. And I've seen a lot of questions on the mailing list for Entity Manager and um, things like that. So I thought I'd give a re-presentation of a presentation I've done before with some new things that I've learned that are questions about Entity Manager. Some of the slides will look similar if you've been to any of the hackathons, but there's some new ones too. And then I'll walk through some examples of things, and then I'll show what it looks like on a S2600 WF, a wolf pass system, from a deep list point of view at least. So goals of Entity Manager originally were to limit the time in platform ports. If you have a lot of platform ports for us originally could take a week or more, month. You have to have a dedicated owner to own a platform, and we didn't like that. We wanted to eliminate hard codes in code for different sort of platforms in our non-open BMC systems. Every now and then a pound define for this if this platform do it this way would happen, and that would be a non-starter. We wanted a centralized place for all of our configuration and some settings. The reason I say some settings is things like BIOS settings and stuff that are common throughout our platforms. We do use settings D for that. So this is more for different configuration type settings that are one time, that sort of thing. Flexibility. We wanted to be able to have any way to any possible detection method to be able to install configuration to say that a card or power supply or something was there. We wanted to not be tied down to any specific method. This is one of the big confusions that comes because of Entity Manager. A lot of people think FRU Device is the only way to discover things. It was designed purposely to not do that. If you look at the probe statement itself, which we can do later, it takes a dbus interface and a key value pair from that interface. FRU Device just happens to be the biggest usage of that, because FRUs are an easy way to determine that EEPROM FRUs are an easy way to determine that something is there. But you could totally write your own application that exposes some sort of dbus interface that says this thing exists and use that to install the configuration. It's also flexible in the means that it'll take anything that any JSON configuration that you want and put it on dbus without any real strict rules. This is done on purpose so that you can have any custom application you want and Entity Manager will still work for it. It more puts a stressing on the consumer to make sure that the data is correct than producing the correct data. We also have, there is some JSON schema that is in the works, but that's more of a build time check to make sure that your code is correct. It was made to be flexible in this way on purpose. It does do inventory as well, just because if you're going out and finding all of the things that you need to configure, you can have the inventory at the same time. It's not quite a one-to-one mapping with a phosphor inventory. That's because they were kind of, Entity Manager kind of being built in parallel. It tried to loop back as well as it could and match things in inventory. But there are some not quite things that need to be cleaned up. We at Intel commonly do a monolithic image for every generation. So one image that supports everything of that generation. So hard codes in device tree and that sort of thing don't work because you'd have to have a different binary for each image. And so Entity Manager, for the most part, allows you to install devices at runtime. It will it exports devices in sysfs for you, and that way you can add devices at runtime instead of at compile time. And then generated SDR was another goal. And this, based on, if you look at Intel IPMI OEM, and I know there's plans to expand this into the rest of the community more, we generate SDRs based on what's on dbus instead of hard coding it. So basic operation, as I mentioned, it probes anything on dbus for any interface key value pair out there. So in most examples, it's FRU Device. I'm not really aware of anything that uses anything other than FRU Device, but it's looking on dbus for some sort of interface. And then it's pretty simple. All it does is take some sort of JSON configuration. When it finds some dbus interface, it puts it on dbus. Entity Manager does not scan any hardware itself. And there was a hard line made between that and Entity Manager, so that Entity Manager was its own configuration system on its own. And then the system configuration is scanned, and it looks for things in the devices.hpp file that match those. And if so, it will export those devices into sysfs, whether it be a TMP75 or a MUX or whatever. MUX symlinks are added, and I have an example of this later. It'll add a symlink into dev so that you know what the MUX you're trying to access is, just because there's no order guarantees for I2C buses, which MUX is which. And then that system configuration is taken and done. We do a best effort fit because JSON is more flexible than dbus to put whatever is in JSON into dbus. And then applications that have dbus matches, such as the sensors, generally have dbus sensors generally have a match that look for any of the configuration items that they care about, and that will cause a reconfigure. PID control also has this ability. Those are the two main ones I know of. So here's a small example of a clamp. So we have a clamp that a lower clipping curve for a front panel. When the item is added, gets thrown on the dbus, and then you get a basic dbus configuration. Everything that Entity Manager exposes that's under the exposes item is under the configuration namespace. That gets put onto dbus, and then that can get consumed, for instance, by Redfish and show up in Redfish, and that same time as PID control is using that. Back to muxes, as I was talking about before. When a mux is installed, if you use the configuration syntax, it will install symlinks in dev I2C mux for you, and you can name for instance here, the slots. And based on this, we have applications that know to look for the configuration, and then the configuration will have the name of the symlink, and then it'll use the symlink to access whatever it needs to access on the other side of that I2C bus. At the same time, FRU Device, while not part of Entity Manager, it has the ability to monitor dev I2C, and so it's monitoring dev I2C the whole time. And so because of this, as you add more muxes, FRU Device then rescans, looks for more devices, and then Entity Manager, when a new device gets added, it gets triggered again. So you kind of get this ping pong effect of discovery of things down the mux chain. I added this just because I heard people weren't aware that Entity Manager could do muxes, and this was an example of that. Before I get into syntax, is there any questions? I know I'm going pretty fast. I guess not. So let's see. Go into power supply example. So this is just on our OpenBMC GitHub. This is just a power supply that I picked at random, and some more features that not everybody for Entity Manager has realized is it can do template syntax. And by template syntax, there is unit tests out there. I would suggest looking at the unit test for more information of what all it can do. But if you have a dollar key, that key is from whatever made the probe pass. So we can go to the probe first, actually. So here's a basic probe. It's looking for anything with the FRU Device interface with a key that has product name and a value that is matching to this power supply. When that's true, in FRU Device, that object is kept and used to fill out any template information in this. So this dollar product manufacturer here is from the past interface that exposed this information. And so by doing that, you can have all this information filled in for you instead of having to hard code whatever is in your system. We also added ability to do basic math operations. For here, we wanted to make sure that power supply 1 was always power supply 1, regardless if you had power supply 1 or if you only had power supply 1 and not power supply 2, and you want to make sure power supply 2 is always 2 even if 1's not there. Originally, it was just taking whatever 1 was found first, but then obviously if you only have 1 power supply, it's always going to be power supply 1. So we added this basic math syntax to be able to take the address, and our addresses are for this power supply are 70 to 74. So we just mod it by 4 and add 1 to get the address. And that way, this one configuration can be used instead of having to have 4 duplicate configurations, 1 for each power supply, even though they're essentially the same power supply. And then this is used throughout the file to identify the rest of the fields in the power supply. So that's how the template. Sorry?
Sorry, James, I had a quick question.
Yeah.
Maybe you cover this later, but some of the key names that show up here in the exposes section,
Sure.
how are those names determined? Is that coming out of a dbus interface, for example, or is it based on the apps that consume the data?
Which ones? So each exposes item has to have a name and a type that's required. Besides that, it's all up to whatever is exposing, consuming the data to whatever it needs. So Entity Manager at that point doesn't care anymore, whatever is in this file. It's whatever, for sensors, for instance, whatever it needs to be able to read the sensor. For fan control, it's whatever the fan control needs. So at that point, Entity Manager doesn't care anymore. It's the consumer.
Okay, but would all power supply config JSONs, for example, would they need to follow a schema of sorts to have the same kind of the key names that show up here? For example, the I know the iLimit max and iLimit min.
So in this instance, this section right here, this exposes item, is to add a PID control. So to add a PID controller, you would need essentially the same information, but maybe there's a power supply without a fan, and so it wouldn't need the section at all.
Okay.
So yes, each exposes in general probably needs the same information just because the consumer is expecting that information. But I know that some things are optional, and so they might not need it. like an optional example is power state for sensors. Power state was a later added feature, so it wasn't needed. So if you don't include power state, it defaults to the sensor is always available. And if you include it, then you can change it to the sensor is only available on power on or after BIOS post, for instance. So it is truly up to the consumer. Entity manager won't ever care.
Okay.
Does the entity manager allocate numbers for the total number of power supplies that it finds of this type?
That's one of two options. So as I was saying down here, the power supply number here, it's taking this template syntax right here, where it takes the address mod 4 plus 1 to assign the power supply 1 in this case, if the address was 70, for instance. But there's also a index specifier you can do. And index will say just increment it out for the number of things of this you found. So in that case, it would just be 1 through n that it found every time.
Okay, thanks.
And yeah, as I was saying, this is kind of there just to keep the left power supply always as power supply 2 and the right power supply always as power supply 1, for instance, just because it'd be confusing to a consumer if they flip-flop the number.
Okay. Yeah, but some of these systems have 4, right?
Yeah, and so that's why in this instance it's mod 4, but just to keep them all the same number always.
So James, for this inventory part, is this per power supply details or is common for the board?
This specifically here, I guess I should have said that a little more. The way that we have it set up, and this is kind of why I said on S2600WF, the original thought was to break up the configuration files into as many removable components as possible. And so this configuration file here is per power supply that we find. It is totally possible if you wanted to write one configuration file for a whole system, and that's just that system, and you don't find things dynamically. We broke them up on purpose so that now that we added support for this power supply, when this power supply is found on any system, it is automatically, it already has support for it, and there's nothing we have to do.
So this power supply has a FRU device.
Yeah, this power supply has a FRU on it. Yeah.
Oh, okay, makes sense.
Yeah. And so if you notice back at the configurations here, we broke, for our systems, we try to break up everything into each individual components as much as possible, because now for all of the basic power supplies that we ever support, we never have to do that again. And so that just makes it easier for people when they want to add new platforms in the future. If they added a known power supply or a known riser or a known front panel, doing the platform port already has a lot of the work done for them. They generally only have to do the baseboard and any chassis components that are changed.
So is there any other way to detect the devices other than the FRU, because you are adding all the new devices based on the FRU found, right?
So that's where I was saying earlier, this is just any dbus interface. That could say XYZ OpenBFC project sensor value interface. It doesn't really matter what the interface is. So far, it's only been the FRU. That's the only one that I know of that's really been used, but you could create your own daemon that does an I2C ping at a special address, and when it finds that address, it installs something. We've actually FRU Device does now support I2C item found at, and we have used that to identify things when the FRU isn't available, but we know if we're on this platform plus this I2C device pings, then that thing is there.
Yeah, so just the last question follow up on this. So the following inventory asset section is only for the FRU device, right? Not because it gets all the data from the FRU component.
That's probably going to be the case. But if you have something else that can, these are templates. So this is just something that came from the passing interface. So if you have something that has those keys and values in it, you could use that as well.
Okay.
Because this is just saying, once you found the passing probe, steal the value from the key that matches this.
Okay.
So it probably will be that way, but it doesn't necessarily have to be that way.
All right. Thanks.
And that's kind of one of the clarifications I'm trying to make is maybe it was a mistake in the first place putting FRU Device in the same repo as Entity Manager, even though they're pretty tightly coupled in most systems, just because there doesn't necessarily have to be any connection between those two. You can use Entity Manager without FRU Device at all. So go ahead.
Entity Manager pull periodically to see what's there?
No, it uses dbus matches to get, whenever there's a properties change signal in any of the probes, it's on first boot up, it'll scan through all of its configuration files looking for the probes and take the interfaces out of them. And then if there's any properties changed or interfaces added, I believe, for any of those interfaces, it'll trigger it to go and look for things that changed.
So if it does see a change, and will it remove things that it had? Yeah. Okay.
Yeah, we do that for power supplies specifically. When power supplies are pulled and removed, it'll remove them.
Okay.
FRU Device does have a rescan method that you can use to make FRU Device force rescan, or it currently rescans every time there's a change in power state. We just left it that way, so if you have some application that's monitoring something, you can call the method that was rescan on dbus if you need it some other time other than those 2 times.
How do you maintain power supply numbering if power supplies are being removed and inserted?
At least on our systems, like I was saying, the I2C address is the same depending on what slot the power supply is plugged into. And so that address right there is being used to keep the index.
Okay.
So I have a question. So when the power supply
in some time or whatever, should we trigger it manually when we, let's say, replace power supply?
Sorry, I missed the first half. There's a couple of people talking at the same time.
I mean, when we replace power supply unit, do we need to trigger FRU Device manually to rescan the buses?
So for dbus sensors, the power supply sensor, when it gets a new power supply added, it continually pings the address of the power supply, and when it changes state, it will call rescan on dbus. So if you're using PSU sensor, I believe it already does that. Otherwise, yeah, you would need to keep a list of possible addresses, and when one of those addresses changed, call rescan. Either that, or you could have FRU Device just random go in a loop. That just seemed inefficient, and so we didn't make it rescan all the time.
Okay.
So I have a question. So when the machine power up with less power supplies than POR, and then these power supplies are used on multiple platforms, so we cannot fix it on an index based on a bus or address, and we have to name it like 0, 1, so that service team can service them better. And in that case, we would like the number getting mixed. So is there like a way to fix the number, the index per platform?
If you wanted to, you can do compound probes. So let's see. For instance, here, this one says when you found a WolfPass baseboard and this could be like your the type of your power supply, and then you would have a configuration for that power supply on that platform. Was probably the way I would do it.
Okay, cool. Thanks.
Is there any conditions in configuration file?
Sorry, what do you mean by conditions?
Well, I mean, can we define one configuration for entire platform and use one on another, I don't know, part of this configuration depend on modification or depend on hardware installed?
So you mean like modify one configuration based on another configuration?
Yeah, kind of.
Yeah, there is the ability to do that. There's a removes syntax where you can delete when. So you say you have the example I have for this is we have one we have one system and it's in an open chassis, so it doesn't have a chassis that has a certain fan clamps, and then when it's a closed chassis, we want to have stricter fan clamps because that platform it's a closed chassis, so the heat restrictions are worse, so we need tighter clamps. And so when that happens, we more or less overlay the chassis configuration on the baseboard configuration, and that removes the clamps from the baseboard configuration and adds the clamps from the chassis configuration without deleting everything from the baseboard. Is that sort of something you're looking at?
Yeah, well, maybe the things that we have slightly similar platform, which differ only in count of the fans and fan connectors, and I don't want to copy entire configuration. I want to only modify fans depending on contents of FRU.
Yeah, that's exactly this situation. So there's a remove syntax that you can use that will delete that. I can find a link for you real quick.
Okay.
It might take me a second, but I'll find a link. If there's any other questions, I can answer those while I'm finding the link.
Well, coming back to power supply unit configuration, you say that you try to make it reusable for all the other systems, but it still uses some kind of system knowledge. Let's say all the fans define it to belong to zone named PCU, which may be maybe on some other system you don't want to include to this zone, you want to include to other zone. Is it possible to modify this value without rewriting of PCU config?
You mean the naming of it?
I mean, if you go back to PCU config.
Yeah. I think it was that one.
Yeah, all this PCU belongs to zone named PCU. I mean PID zone.
Oh, PID zone. Gotcha. Yeah, this guy.
Yeah, this one.
Here, let me find this removes real quick for you. I'm on the page with it. Here we go. Okay, I found it. And this is in the Intel BMC. It hasn't been moved yet. But there's this disable node syntax that was added really recently. Basically, it says in the system, if you find one of these, and this is fans exactly like you were talking about before, to disable that configuration, and then the configuration that's in this file takes precedence then at that point. So it just basically goes and turns off whatever was already in the system.
So does this disable node can be applied to any type of nodes?
It's anything in the exposes, yeah.
Okay,
It just disables anything in the exposes by name.
Fine.
All right, if there's no other questions, I'll show what it looks like on the WolfPath system that I have open. So on our system, this is a dbus viewer that I wrote that just does I2C bus control commands, or sorry, does SSH bus control commands, and so you can see what the system looks like. And so, like as I said before, we have the system broken up as much as possible, and so there's riser configurations, there's a front panel configurations, baseboard configurations, chassis configurations, and then my power supplies. And so based on this, we can also get the inventory on the system made for us when this happens. And so that kind of shows what it looks like when it's completely laid out. If there's anything, I can show any of the configurations if anybody's interested, but that's just the layout of how it looks. And then that helps us. So if I click on like a power supply here, we can get the asset like we were saying. This is pretty much the exact one we just had up on the system, and so it's all filled out for us, and that gets it on dbus. All right. And then the only thing else I had is a couple of future things we were thinking about doing. Stronger JSON validation. Entity Manager does support valid JSON, and it was turned on for a certain point. It did get turned off just because when we were adding more and more configurations all the time, it kept getting broken. Hopefully we can get it turned back on though, so that we can use the JSON schema that that is in the repo to during runtime check and not load configurations if they don't match. Brad Bishop's also worked on some valid JSON or JSON validation stuff that's during build time, I believe. And then at some point, nice to have would be U-boot DTS configuration, and how that changes Entity Manager, I'm not entirely sure. But a lot of this depends on having a very simple DTS configuration. And if you're for a monolithic image, it gets difficult if you have two systems with different I2C topology to support both. So I know Yocto has support to add multiple DTS images and DTS binaries into U-boot. So incorporating that into the flow so that you can have completely separate systems be supported by the same image would be a nice thing to add in the future. That's pretty much all I have, unless there's any other questions or anybody wants me to dive into anything specific. I can pull up Entity Manager and dive into anything if anyone's interested.
Since we have some more time, I'd like to jump back into the Squared C Muxes.
Sure.
So how do I write my configuration file to instantiate Squared C devices behind that mux? So I saw the ability to create the symlink. How do I refer to it in the JSON syntax?
So for our systems, normally the things that are discoverable have something behind the mux so we can tell that it's there. And so at that point, we've been basically just using another FRU probe after that. So now that the mux is there, and any manager can see behind the mux, and it'll scan behind the mux and then add something. There isn't any syntax today to say behind this mux add this card. So that's not supported today. But that would be a cool feature to add because we have rented issues, and so sometimes we just bake the item into, like, for instance, if we know there's a mux with something on it that's typically there, we can just add it to the base work configuration. But that's not ideal because then it's baked into another config.
All right, thanks. That answered my question. I think that the earlier questions about how Mux support works is really around that missing feature. So what I'd like to see,
like something that you can't detect behind a mux, but you just think is there.
So the simplest use case is something like a PCIe expansion card that has an EEPROM on it and also a mux.
Okay.
And there are I2C devices next to the EEPROM, but also behind that mux.
Okay. And the things behind the mux, how do you know that they're there?
The EEPROM in front of the mux is on the same PCB as the mux. And so when you find the EEPROM, you know that there's the mux and devices behind it.
Okay. So at that point, you just need to know, you want some way to map which mux channel that thing is on.
Yeah, so ideally, very, very napkin sort of design. What I'd like is a syntax similar to how you have, $bus. I'd like to be able to say, $bus.mux channel 0 or something, and maybe be able to go up and down the I2C topology.
Okay, so something that might not be 100% there, but let's see, what's something with a mux? When you add the new mux, when you add the mux on that card, it gets named like those channel names I was showing earlier here, and these channel names are symlinks in Dev I2C. So if you were to add that card and you want to know what channel that thing is at, you could refer to it at the named channel.
But can I stick that symbolic name in a $bus field here?
So you want another thing to be, so this name is, so basically what you'd do is you'd have a probe statement that says, when I found the PCIe card, then install this thing, and this thing is hard-coded to say that at U2 slot 1 is my bus, but then you'd have to find some way to decode that back into a number if you wanted to use it as a number. Or you can just use the symlink that's there. I know it's not a full baked answer, but that's the way that I think that you could kind of get there today.
Yeah. So what we ended up doing is we stick the muxes in our device tree so that they have predictable enumerations, and then we use your math feature to compute buses relative to each other.
Okay.
Which got us by for now, but isn't useful on a variety of platforms.
Yeah, one thing that we've ran into is the issue where the EEPROM is behind the mux, and the mux you have no way to.
Yeah, we have one of those too.
You have no way to know that the mux is there.
Yeah, so I mean that I view as a mistake on the hardware design standpoint. So we're making it a requirement on the hardware engineers to never do that again. But yeah, that's another thing we had to deal with.
All right, yeah. If you can file an issue on Entity Manager with the mux problem a little more laid out, then hopefully when next time we touch something in that area, we can hopefully touch it in the way that works for both of us or something.
Yeah, so I'm working on securing some resources to invest, more in the entity manager software stack, and we'll let you know as soon as we have a reasonable proposal.
Okay, cool, thanks.
Yeah. Hi, James. Yeah, I have one question, like generic question on entity managers.
Sure.
So currently, like entity manager supports IPMI interface. Like let's say, like I want to read some host FRU or host sensor data. So it's based on IPMI interface.
Mhm.
So how we can get those data using entity manager? Is it possible to add the JSON configuration file, or entity manager needs to be updated?
So for us, for an Intel IPMI OEM, it actually looks for the FRUs in FRU Device and will print out the FRUs for IPMI tool FRU list, and it looks for the sensors that are available on dbus using the mapper, and will create SDRs on the fly for that. I know that IPMI host today doesn't do that. I saw email conversation about either combining the two or making a switch for using one or the other or something like that. But that's at the will of IPMI maintainers and that sort of thing at this point. There's also been talks about pulling the IPMI FRU Device and Entity Manager specific stuff out of Intel IPMI OEM, Intel IPMI OEM, and putting it into its own library to be shared with more people who want to use it. But today,
That would be very welcome.
but today, the only support that I know of is in Intel IPMI OEM, and I think a couple of the other IPMI OEMs have taken that code as well.
Well, saying that, we also meet a number of problems with BMC Web, not only IPMI. It's also kind of not ready to use this new model.
BMC Web?
BMC Web and Redfish, I mean those from upstream. We need to modify it too much.
No, BMC Web already has full support for it. BMC Web was implemented originally at Intel, so it was originally developed with Entity Manager in mind. It supports both, I believe, but we use Redfish just fine without any changes.
Does it support runtime configuration change?
Yeah, it does. And so it just depends on how you want to retrigger it. Like I said, right now, if you DC cycle your system, it will detect anything that changed. Or there's a rescan method on dbus that power supplies use to, or at least the power supply sensor and DOS sensor uses to trigger a rescan mid-flight to add or remove configurations for power supplies. So either an option, or you can just write a script to rescan whenever you feel like it and call that method.
So is there any way I can make changes to this configuration file from the Redfish, and which can be kicked on in Entity Manager?
Only certain fields. Today there's, let's see, it's probably easier if I just pull it down. Today, for security reasons, we specifically didn't want everything to be able to be changed, but there is this list of, let's see, settable interfaces right here. And so some things we believe make sense changing runtime. So those here being fan profiles, PID zone interfaces, you can see the rest, thresholds. Those are all settable during runtime, and those get persisted in the system JSON file, which is the JSON file that is the combination of everything that Entity Manager found that it stores kind of as a database. And so, for instance, the screenshot I showed earlier of the fan control, all the fan control is modifiable over Redfish at runtime. And that's actually been a pretty good thing for us, is we've been able to let our thermal team make the thermal control for us by setting parameters how they see fit, and we don't have to give them custom end results all the time. They just give us the end result. And so they can modify those through Redfish. There is no way today to upload new files, though, if that's something you're looking into. That's something that's been on our backlog for some sort of time, to be able to add some interface to upload new files at runtime.
Okay, thanks.
Yeah.
I have a question. The configuration is saved in the var configuration system.json, right?
Yeah.
Suppose if I modify the original JSON file and if I do the firmware update, how do I update the system.json file? Do I need to delete manually, or during update it will be taken care?
Today during a firmware update, at least on our systems, this isn't a thing that's, I'm not sure if everybody has an Etsy OS release or not. On our system, at least, there's an Etsy OS release file that Entity Manager takes a hash of, and when that hash changes during a firmware update, then it refreshes the files.
I believe it doesn't work this way because of I have to remove this system JSON file each time I modify my first configuration file, original.
Yeah,
configuration
even
file.
I also face the same issue.
Yeah,
Do you have that Etsy OS release file on your system? I'm not sure how that Etsy OS releases works for everybody.
No, James, I think the HCOS release file is there for everybody. The only reason is it has the major version number, which you would be taking a SHA of that.
Yeah.
And every time people do update, it has the same SHA. The SHA never changes if you're changing one file, because you're not using that OpenBMC version. And that's the reason, if that's not changing, so your Entity Manager doesn't know that anything changes in your firmware.
Okay, so for us, we modified the SEOS release script to have the commit SHA for whatever the current commit is. So whenever the commit changes, it refreshes it. So that might be something.
So you trigger updating this file based on commit number.
Yeah, on the SEOS release, we have the commit in the commit SHA in the OS release file. So that might be a difference that we did.
But isn't during development
during development you have to delete it manually? Yeah.
Yeah, well.
Unless you have a new commit.
I got it, but I guess it would be better to calculate SHA based on configuration files on startup or something like this.
Yeah, we could definitely do that. We could definitely take a SHA of every file that's in var configure or user share. That would work too. We were just trying to do it some way that was something that would change every time that a consumer got a new image. So it wasn't really made for during development.
Yeah, that's true. That's true. You don't need to in real system. You don't need to do this, but during the development, it makes some pain.
Yeah, I'd be fine with having that changed. It wouldn't bother me any, as long as it still works.
You showed the debug objects in a browser, right? Using your tool. It is cool. Is it available somewhere for us to use?
Not yet, but I can push it. I can push it today or something to the scripts repo. It's just like 100 lines of Python. It's nothing big.
Yeah, thank you.
Yeah.
You told that you're going to force check sham when read config, right?
Sorry, force check what?
I mean configuration sham, or how to call it, verify config file based on
Oh, the JSON schema?
yeah, JSON schema, yeah. But do you provide any mechanism to have OEM schemas or something like this that we can use to extend your schema with our own configuration?
So the schema stuff isn't done yet, but I would assume if we were going to do that, we would just kind of do it the same way as we used to do to install the JSON files, where we would just use everything that's in the directory. So all you'd have to do is write a BP append to copy your schema into the directory. The rest of the schema lives, and then it should just work.
Okay.
At least that's how I would see it. Like I said, the schema's been something that's lived and died and waiting for it to come back again, but it hasn't yet.
Oh, by the way, I would like to claim this entity management configuration file to be kind of mess. Especially this expose section, some kind of parameters are handled by entity manager and another just exported to dbus. And I would like to have the syntax which explicitly show which parameters are intended to be handled by entity manager and which parameter I just export to dbus for other consumers. Because of now, it's hard to understand which of them do what.
So like some special character or something, or?
Like you have parameters, I don't know, which handle by dbus sensors with all the thresholds or whatever. And you
Sure.
have other kind of parameters that used by entity manager itself to instantiate devices or GPU, IO, or whatever.
Yeah, the device list is it's a pretty small list, which is probably why it is that way. But
yeah,
it's just a small list of what's there. And besides that, nothing else can be exported. It's just this list. So that's probably why there hasn't been any special syntax. But if you have any ideas of how to make it cleaner.
Yeah, well, I would like to see some keyword like, I don't know, export or whatever.
Some keyword, okay.
Or maybe just separate parameters I need to handle by.
Oh, you mean like a separate config for the exporting versus the sensor?
Yeah, maybe not to place all of them into these exports, or how this is called, but have two different sections, one for experts and another for entity managers.
Not a bad idea. I like it.
This exposes, sorry.
Yeah. Yeah, and I get what you're saying. Have them be separate. That makes sense.
Mm-hmm.
I think it was basically done that way to try to remove the duplicate information, but I see how it could be confusing.
Yeah, and another thing that's confusing me on this PCU description files, you have almost the same config files for line of different PCUs, and it looks like a mess. I believe that when we start to use Entity Manager on all the platforms, we will have just a mess of tons of these JSON files with pretty the same contents. How do you think, can we have one configuration file for example, all the line of similar power supply units and set the threshold based on contents of the FRU of this power supply unit?
So I think that depends on how different vendors set up their systems. Depending on
Well,
different
let's
power
say
supplies, you might want different thresholds, and so or different clamps, or and so I think
well, if you open this power supply unit configuration file.
Sure. So I think I've been clicking on that one. This guy?
Anyone.
Yeah.
Please take a look on thresholds for power, let's say. Upper.
Oh, this guy.
Yeah.
This guy here?
Yeah, this 1648.4. What's that? Where it comes from?
For us, our thresholds come from our thermal team. They just deliver us what the thresholds are. I think they take some sort of max theoretical and subtract some percentage off of it.
To be honest, I don't believe that there is really important to have such precision.
I'm thinking it's based on the math that they did. That was just the answer they got, is what I'm assuming. But I would agree, it probably could just be rounded.
Yeah, well, okay. I just thought that each power supply have this multi-record in PCU where they specify their power, maximum power and other characteristics, and we probably can use this information here to calculate thresholds.
You mean like through getting those through PM bus or something?
No, we generally can use FRU. I know that currently FRU Device doesn't support multi-record, but we can add this support and export information from this multi-record section in FRU, and then use it to calculate thresholds here.
Yeah, that'd be cool. Yeah, you could do that. I didn't know that was available in the FRU.
Okay.
So James, one question on the GPIO. So does it expose the GPIO from the entity manager so it exports?
For GPIO, we stopped using that. There might be some remnants of it. We might have left it in there in case people want to use it, but for the most part, we've been using libgpio and defining all the GPIO in device tree, and then using the GPIO name and libgpiod to get the GPIO. It just because it sounds like it's the SysFS is the bad way to do it, and everyone's moving to character device, so we went that direction. Okay.
And one last question on this is like, if I have two configuration files for my board, and one probes to the FRU, another probes through something else, and so I can have both the files, and Entity Manager will detect both of them, right?
Yeah.
Okay.
Yeah, that's the preferred way of doing it, is to separate it out, just so if you have that secondary card on a different platform, then you use the same configuration for both.
Sure.
Okay. Thanks a lot, James.
Yeah.
Any last minute questions? I think we are almost end of our time. If not, yeah. Thanks a lot, James. It's a wonderful session.
Bye.
Bye.
Thank you very much.
Thank you.